Hello again, everyone. This is Earth Science teacher Tim Martin, and in Meteorology Part 21, we'll take a look at factors that affect climate. Climate may often be described as weather over a long period of time. Technically speaking, we usually discuss this as part of a 30-year average. A well-known climate scientist I once talked to said weather could represent the clothes you are wearing today, where climate represents all the clothes in your closet. You see, if you live in a place like this, Death Valley, I'm sure your wardrobe would have lots of light, warm weather clothes. On the other hand, in a place like Siberia, your wardrobe would look a bit different. For me, since I tend to travel and have a few adventures, my closet may not be the best representation of this analogy, so maybe I should change that to the clothes in my suitcase, because my closet may have desert clothes or Arctic wear. So what are some of the factors that affect what climate is like? What will our weather look like over long periods of time? The location on the curved surface of the Earth will dictate the amount of sunlight that's absorbed. Latitude, and therefore the absorption of solar energy, is without a doubt the most important factor that affects climate. The closer you are to direct sunlight, the more likely for warm weather. The further from that direct sunlight, the more likely to see cold weather. Right along with latitude, another very important factor that affects climate is topography, specifically elevation. This was very dramatic when I recently traveled to Hawaii. You can see in this picture of Mauna Kea, the largest mountain in the world, when you measure from the base of the mountain below the sea to the summit. In this image, you can see very distinct bands of climate zones or vegetation patterns. Down low, there's very dense jungle-like forest. A little higher up, the forest gives way to shrubs, eventually to grasslands, and the summit of the mountain is dominated by a rocky alpine desert. This can be seen in many mountainous regions throughout the country. Here we see the mountains in Colorado. The higher up in the mountains you go, the shorter the trees get. Eventually they give way to shrubs above the timberline, and there are places where there is snow year-round. High elevation, just like high latitude, may dramatically affect the climate of a region. Another aspect of topography is the north-south slope aspect. We'll notice that one side of the mountain has trees, the other side is barren. It was particularly confusing when I noted that the north side is the side that had trees. Originally, I thought maybe the south side would have the trees because of access to more sunlight. This similar image from the mountains in Utah helps explain this. On the north side of the mountains, the snow lingers longer. This is really a story of water. The northern slope does not dry out as fast. Another major factor that affects climates around the world is that of ocean currents. You'll notice this map from the National Oceanic and Atmospheric Administration shows ocean currents around the planet. You may recognize that many east coast currents, or the western side of the ocean basins, are warm, whereas the west coast, or the eastern side of the ocean basin, often has a cold ocean current. This dramatically impacts weather. We can take a look at a few specific ocean currents. The Gulf Stream. Warm water comes between Cuba and Florida up along the coast of North America before it hits Cape Hatteras on the North Carolina coast and heads out across the Atlantic over towards Europe. The warm water moderates the climate of those regions. Another dominant ocean current that affects much of the world's weather is the El Niño-La Niña, or ENSO. This oscillation of warm and cool waters in the Pacific has dramatic effects on temperature and precipitation patterns around the world. Of course, for those of you who like to watch good movies, you should be familiar with another ocean current. Yes, your favorite, Crush. He's often riding the EAC, the East Australian Current. Beyond ocean currents and topography, wind plays a major factor in understanding climates. This ought to look very familiar to you, as you drew it in class many times. There's a few aspects of the diagram that we did not discuss earlier in class. Specifically, I'd like to call your attention to the clouds on the left-hand side. Notice that every place we see rising air, clouds are indicated. You'll also notice on the earth below, they tend to be green. Every place we have sinking air, the high pressure zones, tend to be brown. Let's examine that a little further. Global wind patterns dramatically affect climate, particularly the areas between the winds. This band, near the doldrums, is characterized by a lot of rising air. This is where all the world's great tropical rainforests are located. From the Amazon to the Congo to the islands of Borneo and New Guinea, the world's great tropical rainforests are all located near the doldrums. A little higher latitude, we find these brown stripes across the planet. The horse latitudes are characterized by sinking air. Areas of high pressure are where we find all the mid-latitude deserts. From the American Southwest to the Sahara, the Arabian Peninsula, to the Gobi and Talamancan deserts of Asia. In the southern hemisphere, we see the Atacama and Kalahari deserts and the great outback of Western Australia. All of these areas are located in the horse latitudes. Further to the north, we'll see a stripe of green. This area is where the polar front is located. Again, an area of rising air, we'll see the mid-latitude temperate forests. This is only found in the northern hemisphere because the southern hemisphere at this latitude is dominated by the Southern Ocean. Finally, at the far extremes, at the poles, we see the polar high. Although there is snow here, the total amount of precipitation is quite low, leading to polar deserts. So once again, you can see by looking at these photographs of the planet, the areas of green and brown, green and white represent the rising and sinking air around the planet. A bit more about the wind. In the zones of prevailing wind, we can also have dramatic climate effects. This was very obvious when I recently visited Hawaii. Hawaii is located in the northeast trade winds. On the eastern side of the island were thick jungles, tropical rainforest with almost every imaginable type of plant. On the other side of the island, large dry grasslands and dry deserts, even cacti were common. So why do we have dramatic climate zones just on one small island? Let's take a look at Surfer Girl once again. There are two words that we frequently discussed when talking about wind in a mountain range. We have the windward side and the leeward side. The windward side is the side of the mountain into the wind. As air, particularly off the ocean, moves up and over the mountain, clouds may form. Of course, those clouds may produce precipitation, rain, and fog. That may lead to growing of forests. On the leeward side of the island, as air moves down over the mountain, it has already dried out, and so we talk about the rain shadow on the downslope side. This may lead to dry land vegetation. This, of course, is very dramatic in the western United States. Here we see central California. California is located in the westerlies. Let's take a look specifically at this white zone, the Sierra Mountains. On the western side, we'll see thick, large forests. These aren't just any forests, though. Looking closer, these forests contain some of the largest trees on the entire planet. On the other side, the mountains give way to desert, like I said earlier, characterized by dry land vegetation. A note about U.S. history: in this inhospitable location is where the United States imprisoned Japanese Americans during World War II. Here's a view of Manzanar, which is an internment camp just on the eastern side of the Sierra. But once again, coming back to the satellite image, you'll notice the green on the windward or westward side of the mountains. The snow gives way to desert quickly on the leeward or eastern side of those mountains. Monsoons are seasonally shifting winds. No place are the monsoons as famous as that of India. Notice here, air rises over the subcontinent of India. The replacement air comes off the Indian Ocean. The winds with those colliding air masses bring significant moisture, so the monsoons do eventually bring rains to most of India. There are also monsoons in the American Southwest. Late summer thunderstorms often result from a monsoon flow over Arizona. Another factor that affects climate are seasonal katabatic winds. Katabatic winds are downslope warming winds. A famous example of this in the United States is the Chinook, which happens over the mountains of Colorado. As an air mass over the mountains of Colorado moves downslope heating can occur, causing the air temperatures to rise more than 50 degrees. A 20-degree morning with snow along the Front Range in cities like Denver can quickly turn into an afternoon where the temperatures reach as high as 70 degrees Fahrenheit. Another dramatic katabatic wind is the Santa Ana. When a high pressure builds over the Mojave Desert in the American Southwest, downslope flow towards the Pacific Ocean can have dramatic effects. If the air is already hot over the desert, it can heat even more as it moves downslope. This is known to particularly exacerbate fire danger. One time I was visiting California, I stepped outside and quickly saw the sky was turning gray with smoke. Fire was all around this neighborhood. It wasn't long before helicopters and later planes came to fight the fire. Notice the altitude of this airplane and also notice the position of the power lines. Seeing a plane flying below the level of power lines is quite an impressive sight. Fortunately for the people in the neighborhood, the firefighters were able to contain this fire, keep it from moving into the neighborhood and growing out of control. That said, frequently fire does get out of control. Here we see fires burning all around the Los Angeles basin. For the last several years, the fire season has been particularly bad in the American Southwest. In our next video, we'll take a look at different climate zones around the world. Thanks for watching, and have a great day.